So we use BIM every day to model complex timber structures, and it really informs pretty much every step of what we do at our company. So we're a company that takes structures right from conception and structural design through to fabrication and installation on site. So building information modeling in one way, shape, or form really touches every single part of that process. It touches us when we're bidding a project. We do preliminary models for takeoffs. Then when we go out for quotes for material supply, we use 3D models. Then when we start making structural drawings or analyses, 3D models are all linked to the building information model. Right through to fabrication, where we send out CNC files to CNC machines, and the timber elements get cut with a computer numerically controlled machine, basically. Right through to erection, where I was showing a bit today how we use four-dimensional building information modeling to actually really show the sequence of events as a building gets constructed, right from looking at how stacks of materials are on a truck through to the exact sequence of every element of the structure getting dropped into place and actually constructing the building. I think we're going to see BIM becoming much more pervasive. We're going to be seeing a single source model, a central model governing everything, and very much more accessible than it is today. Right now, building information models are often, particularly for large buildings or large structures or integrated systems, are often only really usable by people with either special skills or very powerful computers. You can see it on your tablet, but it's laggy, it's slow. You may not be seeing the type of information that you actually need to get out of that model for it to really be able to help you build the structure. So I think what we're going to see is we're going to see a significant step change in software. We're going to see web-based software primarily, no more desktop-based packages, and we're going to see that software be able to intuitively tell you about the structure, everything you need to know to first both be able to construct it, but also to be able to monitor it as you move into a post-occupancy use and see how the building's actually performing, so connecting to sensors and this type of thing. Building information modeling affects everyone. I mean, it's a skill set. Our skill sets as designers have had to change completely in the last 50 years. From pencil and paper and thinking everything conceptually through in your mind to really being able to see everything in a three-dimensional model, clash detection, this type of thing. So it really actually changes how a designer thinks. This whole concept of doing everything in 3D. And I think it's also changing, slowly starting to change how owners think about their buildings and how they think about managing their buildings long term and how they think about the cost of a building, because 80 to 90% of the cost of a building is during the use of the building. So if you can start to take those models that are made up early in the project and actually use them to monitor your building's performance, you can get a lot more bang for the input you put in early on. So one of the problems I think we see at the moment in the industry is the building industry in general is a very fragmented industry. A lot of small players and a few larger players, particularly in civils, but also in building construction, but not big enough companies to invest large amounts of money in R&D. If you go to look at the aerospace industry or even the film industry or the automotive industry, it's really quite a lot different. Big companies, repeatable products, significant money to spend on making software that does exactly what they need it to do. Because we're a fragmented industry, we've seen that hasn't happened here. And we're only slowly starting to see big players like Autodesk and other players start to kind of really advance software to where it needs to be. So I think in the next 10 years, we're likely going to see people like Silicon Valley startups coming up with maybe slightly radical new ideas about how building information modeling should be implemented in a software sense, how we should be able to interact with the model. Because I think BIM is all about communication. And if we can't communicate and we can't interact with that model, then it becomes a silo and we have to go back to our typical drawing sets. And so what I think, I gave an example earlier with the Lionsgate Bridge. That bridge was done in 5 to 10 drawings, 5 to 10 big drawings for the whole Lionsgate Bridge. That's a huge structure. And the draftsman back in the day managed to fit all that detail onto that number of sheets of paper. That means it's eminently communicatable. All you need to do is look at 5 to 10 sets of drawings and you have the entire picture of what that structure is. And now with, when we moved into CAD, we started to see a plethora of drawings with no real coherence or well laid out thinking as to how they were put together. And I think what we're going to start to see is, as building information modeling, 3D modeling takes back the mantle, as it were, now all of a sudden we go back to that place of being able to have a single source of all the information. So we no longer have to look in 5 sets of drawings and 50 different sheets to get an idea of what on earth is going on in this building. So I think that's really something we can look forward to in the next 10 to 15 years.